Imagine a midnight holiday mega sale. Millions of people have their fingers hovering over the Buy Now button, all clicking at the exact same second. Every one of those clicks is a digital request, a tiny package of data demanding an immediate response from the store's website. And originally, all of that traffic was funneled straight into a single computer. A single computer can only process so much math at once. Under the weight of millions of simultaneous requests, the processor maxes out, it overheats, and the entire website crashes. To fix this, engineers add more hardware. Instead of relying on one computer to do all the work, they set up a fleet of 10 or 20 servers to share the burden. But a fleet of computers creates a new problem. When that massive wave of internet traffic arrives, the digital requests have no way to know which specific server has free space and which one is already full. To direct the crowd, you place a system called a load balancer at the front gate. It acts as a traffic cop, catching every incoming request and pointing it down an open lane so that no single computer gets overwhelmed and the site remains responsive. To move this much traffic without a mistake, the load balancer follows strict mathematical rules called algorithms to decide where each person should go. The simplest rule, round robin, distributes traffic sequentially, server 1, 2, 3. If server 1 gets stacked with long tasks, least connections routes new requests to empty servers. Finally, weighted round robin sends a larger traffic share to servers with the most muscle. By applying these rules, the load balancer ensures every piece of hardware is used effectively, keeping the website fast for the user even during a massive traffic spike. Routing traffic perfectly is great, but it creates a memory problem. If you log in and put a pair of shoes in your digital cart, and your next click goes to a totally different server, it won't recognize you. Here we see a solution called sticky sessions. The balancer takes your unique internet address and creates a permanent signature, locking you onto a specific path leading back to the exact server holding your cart data. But what happens if the hardware inside that specific server fails? The load balancer constantly taps every machine to verify they are awake. When a server fails and turns gray, the balancer instantly deletes its path, rerouting everyone to healthy machines. Combining dedicated memory with constant health checks means the system keeps running even when things break. A server can physically burn out in a data center halfway across the country, and the website stays up like nothing happened. Network engineers have two different ways to set up this traffic cop. The first is a Layer 4 load balancer. Think of this like a security guard who only looks at the outside of an envelope, the address and port, to quickly route traffic. This guard operates at high speeds, but cannot see the actual context of your request. They have no way to tell if you are asking for a simple text file or a heavy high-definition video. For more complex tasks, we use a Layer 7 load balancer. This is a more investigative guard who actually opens the envelope to read the specific data you are requesting. This animation shows Layer 7 in action. As incoming packets are opened, the balancer identifies the content, sorting heavy video requests down a dedicated path to specialized video servers, while images go to another group. Because it understands the content of your request, Layer 7 routing allows modern applications to deliver high-quality media efficiently without clogging up the rest of the system. In a fraction of a millisecond, thousands of digital envelopes are being opened, inspected, checked for server health, and mathematically sorted down the exact right wire. When midnight strikes on that holiday mega sale, the architecture holds steady. The millions of people clicking Buy Now are seamlessly organized into manageable lanes. Behind every smooth video stream and reliable online payment you use daily, a load balancer is acting as an invisible shield, ensuring that no matter how many people log on, the digital systems we rely on stay stable and responsive. To learn more about how technology works behind the scenes, hit the subscribe button